All right, we're going to take a look at equations with fractions and decimals. And what I mean by that are equations that have more than one fraction or have a fraction that's not a coefficient. So it's going to make it a little bit more challenging to solve. And what's great is that we have a little trick for these problems to make them much easier. So we're going to break our page up like normal. Our title is equations with fractions and decimals. And then go ahead and break your page up like usual for our notes. You can pause the video until you're all set and then kind of rejoin us. All right, so in example 1, we're going to deal with fractions. So we're going to take the example 1/3 x plus 3/4 equals 1/2 subtract 2/3 x. All right, so notice that we have a lot of different fractions in this, and we could absolutely create a common denominator and then do things as we normally do by moving our variables over to one side and then going from there. But when we have this many fractions, sometimes it's easier to just eliminate the denominators altogether, but we have to do that in a really smart way. So what we're going to do is our first step is going to be to determine the common denominator. And that's for all of the fractions that I have in my equation. So I'm looking for the common denominator between 3, 4, and 2. So I'm looking for a common multiple that 3, 4, and 2 all share. The least common multiple that 3, 4, and 2 all share. So if I start building by 4, because that's my larger number, I have 4. Well, 3 and 2 don't divide into 4, so that's not going to work. Then I'm moving to 8. Well, 3 doesn't go into 8, so that doesn't work. Then I go to 12. And 3, 4, and 2 are all factors of 12. So my second step, step 2, is going to be to multiply each term by the common denominator. So I'm going to go ahead and I'm going to take this equation and I'm going to multiply the entire equation by 12 because the common denominator that we got was 12. All right, so when I do that, I'm distributing this 12 to every single term inside that equation. So I'm going to have 12 over 1 times 1/3 x. I'm going to distribute it to that first term, plus 12 over 1 times 3/4 equals 12 over 1 times 1/2, subtract 12 over 1 times 2/3 x. So again, I multiplied every single term by 12 over 1. Now what's going to be really helpful is because this is a common denominator, I should be able to cross-cancel for every single fraction that I have. So looking at this first situation, I have 12 over 1 times 1/3. Well, I know that 3 divides into both of these, and so I can simplify this expression down to 4 times x or 4x. So again, you can think of it as two different ways. I did 12 divided by 3 and got 4, or you can think about how they cross cancel. 3 divides into 3 one time, and 3 divides into 12 4 times. I'm going to keep on going across. I can cross cancel again. 4 divided by 4 is 1. 4 goes into 12 3 times, so I have 3 times 3, which is 9. Again, I'm going to cross cancel. 2 goes into 2 one time. 12 divided by 2 is 6. 6 times 1 is 6. And then lastly, I'm dividing this 12 and 3. I get a 1 and I get a 4. So 4 times 2 gives me 8x. So what I've done by multiplying every term by that common denominator is I've completely eliminated any denominator. So now I just have a equation with variables on both sides. I'm going to go ahead and add 8x to both sides. I get 12x plus 9 equals 6. I'm going to subtract 9 from each side. I have 12x equals a negative 3, and I divide by 12. It makes sense that I could potentially be getting fractional answers because I started with such a heavy fraction-loaded equation at the beginning. So if you're getting a fractional answer, don't think that you did something wrong. I'm going to go ahead and simplify this. I see that 3 goes into itself and 12, so I'm going to divide both my numerator and my denominator by 3 to simplify this fraction. And so my end result is x equals negative 1 over 4. So just to recap, we looked at our equation, we saw that it was pretty heavy in fractions, and so we found a common denominator and multiplied each term by the common denominator. Example 2 is going to be one that involves decimals. So we're going to have 0.5x subtract 1.2 equals 3.25. All right, so now in this equation, notice I have a ton of decimals, which is fine. Like we could absolutely solve this, especially with a calculator with decimals, but if we don't have a calculator, we want a strategy to be able to reason this out without one. So the first thing we're going to do is to figure out our place value and see what's the maximum number of spaces I have after my decimal, to the right of my decimal. And so notice that I have 1 here, I have one number to the right, I have the tenths place. This one has a tenths place. This one has 0.25, which means it's 25 hundredths. So this one has a hundredths place. So since it goes all the way to the hundredths, I'm going to take that maximum one, which is 2 decimal places after, or hundredths, and I'm going to multiply every term in this equation by 100. Because what that's going to do is completely eliminate any decimals from my equation. So just as before, that's going to get distributed to every single term within my equation, because what I do to one side of an equation, I have to do to the other. So if I have 0.05 times 100, I'm moving that decimal over 2 places, and I'm going to end up with 50x. If I multiply 1.2 times 100, my decimal's right here, I'm moving it over 2 spaces. I have that empty space, I'm going to fill it with a 0, just like I did with the 50. Now I have subtract 120 equals, move it over 2 spaces, I have 325. And now again, I have just a normal equation to solve. I'm going to add 120 to both sides. I have 50x equals 445, and then I'm dividing by 50. X equals, I see that they end in 0 and 5, so I'm just going to divide them both by 5. 5 goes into that 89 times, goes in 10 times, and so I'm left with 89 tenths, which is a great answer, or 8.9, or you could also write this as 8 and 9 tenths. Whatever works for you works for me. All right. For example 3, we're going to bounce back to our fractions for just a minute because I want to show you one thing that can happen. Let's say we have 1/2 times 2/3 x plus 4 all equals 1/6. In this situation, we want to do our distribution first before we multiply by everything. You don't have to. If you're good in understanding that this is counting as one term, so I'd be multiplying the common denominator just by this outside expression, that's totally fine. However, I find that that gets a little bit messy sometimes. So I would recommend doing your distributive property first before you multiply by your common denominator. So let's give that a try. I'm doing 1/2 times 2/3. I'm going to write that out because that's a little bit trickier. And then 1/2 times 4, which is half of 4, so just 2. My 2's cancel, so I'm left with 1/3 x plus 2 equals 1/6. From example 1, we're going to look for a common denominator. Our common denominator between 3 and 6 is going to be 6. So I'm going to multiply everything in this equation by 6. So 1/3 times 6 times I'm multiplying everything by 6. 6 times 2 and 6 times 1/6. So 6 times 1/3, or a third of 6, is just 2x. Again, cancel that out, divide by 3, I get 2, plus 12 equals 1, because my 2 6's cancel. I subtract 12, and I divide by 2. And again, if this fraction, even though it's improper, is simplified, that is a totally justifiable answer. All right, write some notes to yourself that you may need, and then you can go ahead and try the problem set.